Good morning, boys. Today we will discuss about structure of atom. An atom, the smallest indivisible particle. The subatomic particles present in an atom are protons, electrons, and neutrons. Protons are positively charged, electrons are negatively charged, and neutrons are chargeless particles. Dalton's atomic theory. All matter is composed of tiny particles called atoms. All matter is composed of tiny particles called atoms. Atoms cannot be divided up into smaller particles and they cannot be destroyed. That means atoms can neither be created nor destroyed. Atoms of an element all have the same mass and properties. Atoms of an element all have the same mass and properties. The atoms of different elements have different masses and different properties. For example, you are considering two elements, oxygen and nitrogen. Their atoms are entirely different in their mass and their properties. Atoms combine in simple whole numbers when they form compounds. For example, hydrogen combines with oxygen to form water. Next one, Thomson's atomic model. This Thomson's atomic model, popularly known as plum pudding model or watermelon model. Look at this diagram. According to Thomson's atomic model or plum pudding model, an atom that consists of a negatively charged particles, and that negatively charged particles are called electrons. These dotted lines, this dotted part, and that is embedded in a positively charged sphere. You can see there is a sphere. In that sphere, the negatively charged particles are embedded in it. An atom is considered to be neutral, electrically neutral, because the total negative charge is balanced with the total positive charge. The total number of positive and negative charges are equal, so an atom is electrically neutral. This Thomson's atomic model, another way known as Thomson's plum pudding model or watermelon model. The postulates of Thomson's plum pudding model. An atom consists of negatively charged particles called electrons embedded throughout a positively charged sphere. An atom is electrically neutral. The total negative charge is balanced by a total positive charge. Next one, gold foil experiment. Ernest Rutherford was born and raised in New Zealand, and after his successful studies on electricity and magnetism, he moved to Cambridge University in England to work with J.J. Thomson. He spent time studying radioactive materials and the radiation that they produced with Paul Williard, and they discovered there are three types of radiations are there: alpha particles, beta particles, and gamma rays. Rutherford experiment. is known as alpha scattering experiment or gold foil experiment. The alpha scattering experiment, also known as Rutherford gold foil experiment, was a groundbreaking experiment in 1909 led by Ernest Rutherford. It was designed to explore the structure of atom. Look at this diagram. The experimental setup. There is a radiation source. Here the radioactive material radium that produce alpha particles. These alpha particles are positively charged particles. There is a thin gold foil. Behind the foil, there was a screen, that's a fluorescent screen. When this alpha particle hit on the fluorescent screen, there you can see a glow. This is the experimental setup. During the experimental time, the scientist fired alpha particles. The alpha particles are positively charged particles and they allowed to pass through a thin gold foil. Behind the gold foil, you can see there is a fluorescent screen that would glow when alpha particle hit on it. When this alpha particles are passed through the thin gold foil, they observed certain things. The first observation was most of the alpha particles pass through the foil. You can see most of the alpha particles are passed through the foil. Surprisingly, some were deflected at large angles. Some of them deflected and a few of them bounced back. A few of them bounced back. Based on these three observations, they conclude one experiment has observation and there is a theoretical conclusion. Rutherford concluded that the positive charge in an atom isn't spread out but concentrated in a tiny dense region called nucleus. His assumption, his conclusion, the first conclusion was the positive charge is concentrated at the center and that center is called a nucleus. When this alpha particles also positively charged, when they directly hit on the center part, it will be deflected back. So that is the first assumption. He mentioned most of the alpha particles travel through the foil without any deflection. That means most of the alpha particles travel undeflected. His interpretation, his conclusion, the atom is mostly empty. The atom is mostly empty. That's why the alpha particles travel through the gold foil without any deflection. That means they travel through the foil undeflected. Second observation, some alpha particles deflected by small angles. The reason or the conclusion, the nucleus is positively charged and the alpha particle also positively charged, then there is a deflection happened at a small angle. A few of them, alpha particles, they travel back from the foil because the center part, the nucleus, contain positive charge. The alpha particle hit on the exact nucleus, that rays rebound back, that is reverse back on the same path. Look at this diagram. There's a radioactive source. Alpha particles are coming and most of the alpha particles pass through the gold foil. Some of the alpha particles deflected by small angles and a few of them bounce back. They came back on the same way.